Okay, so we're going to kind of do like this is one of the labs like kind of you have to do as part of the AP curriculum. And if there's ever a lab that has tremendous amount of potential for error, this is it. But it also gives you an idea of the difficulty in trying to find the molar mass of a substance because there's so much that can go wrong. So here's the broad idea, is that this is that equation that we came up with on Tuesday, where the molar mass equals mass over, I'm sorry, I solved that wrong. So it's MRT over PV. So here's the basic idea, is that there's a couple of things that you're going to need to know. Number one, and this by itself creates a technical problem. Like, you're going to have these little pipettes, and I've stretched them out so that the end is thinner. And one of the things you have to find is the mass of the gas inside of here, okay? Which in and of itself creates a challenge. So let me kind of paint the big picture of what you're going to need to do. So you're going to have three of these, okay? Now, there's three different liquids that we're going to use: acetone, isopropyl alcohol, and I can't remember the third one. There's going to be three of them. Ideally, I would have you do all three. We don't have time. So, like, basically, each group is just going to do, like, acetone or isopropyl or whatever that is, okay? So, but you're going to do three trials of the same thing. So, if you look over here on this third page here, one that's got, like, experiment 9 and all the data tables. So, you're going to need, and this is very important in how you sequence this. So you need to find, and I don't have Sharpies, and label each one 1, 2, or 3. So you got to keep track of them. And I'm going to have the big fancy scales out. So you're going to have the mass of the empty pipettes, okay? So then there's a couple of things that you're going to need. So once you get that, before you put anything in it, so you're going to take that and then you're going to suck up, like, for example, your group wants to do acetone. Okay, so you're going to put some acetone, maybe a couple of milliliters into each one of these. So you're going to have all three of them. You're going to find the empty mass of each one, keep track of which one is which. And then once you get them filled up, not filled up, but up to about here, then you're going to put them in this piece of rubber hosing so that they're all together like this, okay? So imagine that each one is filled up about a centimeter up with whatever liquid you're going to have. Again, if you can do acetone, fill all three up with acetone. If you're going to do isopropyl alcohol, fill all three up with isopropyl alcohol, okay? Don't do like ethyl alcohol, that was the third one. So don't do like one ethyl alcohol, one acetone, and one isopropyl. No. Your group is going to do one of the three, but you're going to fill the pipettes up with all three. Once you get that done, and the first thing that you really need to do when you get over to the lab is get a hot water bath going. So all of these liquids have boiling points below the boiling point of the water. So get a hot water bath going, find the mass of these, and then you'll notice there's a diagram that shows you kind of what to do over here on the second page where it's got like a test tube clamp, because these things are going to want to float up because they're mostly going to be filled with air. So you're going to have a test tube clamp, and then you're going to submerge these pipettes below the water. And then that way what's going to happen is that these liquids in here are going to reach their boiling point, and then they're going to begin to boil off. So in an ideal world, okay, in an ideal world, what would happen is that these would all boil off, and then this thing would get completely filled with that vapor, okay? So these would boil, and these would all come out. So the reason that you need to submerge these mostly in the water is because if you only have the bottoms, so if here's your water level, and you only have the bottoms, what's going to happen is that this stuff is going to boil, but then it's going to hit that cold air up above it, and then it's just going to condense and it's going to fall right back down. So you'll never be able to get it to boil. So that's why you need to have the vast majority of this below the water level so that it'll boil and then go out, so that that way it isn't just condensing and rolling back down in, because you're never going to win, okay? So in the procedure, it says to do this for like 5 minutes. If you can look and you can see that like most of that, you're not going to get all of it to boil, but you should be able to get the vast majority of it boiled off. And then you're going to take this and then you're going to submerge this whole thing in another beaker of room temperature water, with the idea being that once you submerge it in that room temperature water, then that will immediately take that hot vapor of the isopropyl alcohol, the acetone, whatever that is, and then boom, it gets cold, it gets really sticky, and it condenses into a liquid, okay? So that's the idea, is that you boil it off, you get it filled with that vapor, you take it out, you put it in colder water, boom, it condenses. That's a huge assumption that you're going to make. Now, in reality, what happens is that you actually, when that condenses, you're actually going to draw in nitrogen and oxygen, because you're not doing this in a vacuum, okay? So you're going to have some nitrogen and oxygen in there with it. Eventually, yeah, you're going to start off and you're going to have nothing but the acetone or whatever in there. But as soon as it condenses and that takes up less space, it's going to draw in air to make up that difference so that the pressure is equalized. So you kind of have to assume that, yeah, we're going to have the condensed liquid in here, but really there's going to be some nitrogen and oxygen in it too. So you're going to need the mass afterwards. So this is going to be coming out of water. So what you want to do as quickly as possible, oh, you guys get to use paper towels, is dry these off. Okay, so you're going to have this little bit of liquid in the bottom of them. Dry it off so you don't have the water on them. So then you're going to find the mass afterwards. So over here on this second page, where it's got, like for example, and again, you're only going to do one of these. So you're going to have the mass of the pipette of the condensed ethyl alcohol. Okay, so you're going to have the mass of the empty one. Then you're going to let it boil. Let that condense, dry it off, you can have that. So then you can find the mass of the condensed ethyl alcohol, or whichever one that is. So where on that where it has that, you're only going to fill in the one line for whichever one that you have. Okay? You're not going to do all three, you're only going to do that one. So, but you're going to have 3 trials of that. So the next thing that you're going to need to know, so that will get you the mass of the gas in the pipette. The R is going to be your gas law constant. The temperature is going to be the temperature of the water, okay? All right? So whatever that is. So you need to measure that temperature. That's going to be the temperature of the water. That's the hot water, not the cold water. That's the warm water, okay? Now, the pressure, I'll get you the pressure. I got to check. The pressure's kind of been all over the place today because of the weather, so I'll get you the pressure. Now, the tricky part comes with the volume, okay? How do you find the volume of that pipette? So here's what you're going to do. And again, this is why it's so important that you do this in sequence. So you're going to have the first thing before you do anything, you're going to have the mass of the empty pipette. So the next, after you get done with the liquid, the alcohol, the acetone, whatever that is, okay, then and only then are you going to fill this thing up completely with water, okay? So here's the basic idea, is that if you fill that thing up completely with water, so here's this pipette, boom, filled up completely with water. And you're gonna know the density of the water is, say, 1,000 grams per cubic centimeter. So if you know the density of the water, and you know that that's mass divided by volume, and if you can find the mass of the water inside the pipettes, then you can find the volume of the pipettes. So we're going to find the volume of the pipettes by filling it up with water, and then knowing the density of water, then we're going to find the volume of the pipette. Then, and only then, can we go to this equation. Okay, at that point, we're going to know the mass of the gas in there. Okay, that is not the mass of the water. That's the mass of the volatile liquid. You know the ideal gas law constant. You know the temperature of the water. Make sure the temperature is in what units?
Kelvin.
Kelvin. I'll give you the pressure. I'll look at what that is. And then at that point, you're going to know the volume of the pipettes. From there, you can try and figure out the molar mass. So there's a whole bunch of errors that can happen.
We got this.
Okay? There are so many things where this can go wrong.
We got this.
Because you're dealing with such small quantities, like you get like one extra drop of water, you dry it off completely, and you have water on there, oh, that immediately turns it into a train wreck, okay? So, here's the first thing you need to do. I cannot emphasize this enough. Find the masses of them dry. Get your hot water bath going. So, what you're going to look at, and all this is kind of giving you some simple, an example. So over here on the back of page 1, right, it's got like some sample data. And so on this sample data, and you need to do this, okay, this is like part of the lab. I emphasize this on another sheet of paper, okay? On another sheet of paper, you're gonna do this. Not here, okay? You can write your answers in here, but the calculations are going to be on another sheet of paper. And the whole point being is that, hey, can you use this data to come up with a value? Now, this one actually works out really, really nicely, and you get a very small experimental error. So what you're going to hand in is this preset lab set of calculations. Then over here on this last page, you've got lab question 2A, lab question 2B. Those questions are down here underneath this data table. So here's question 2A. Answer that on that last page. Question 2B. Answer that on the last page. So the questions are here, but I want the answers on that last page. Okay, does that make sense? Then you've got these questions to answer. It's got the structure. I don't expect you to know the structure. This is why we have the internet, okay? So just draw the structures, okay? Look it up. Hey, what do the structures look like? Then you're also going to need the accepted boiling points of each one, and then just these questions to answer right there. So it's a relatively short lab write-up. Okay, are we good? Got it, Rand? Let's hopefully go do some science that works out relatively fast.
Oh.